Okay, so this video will be talking about why fuse must be placed on a live wire. Okay, so normally fuse, if you look at the electrical circuit, right, fuse will normally be placed on the live wire and must be before the switch. Okay, so later I'll talk about why must be before the switch. Okay, so in the event that there is maybe a electrical fault, so what do I mean by electrical fault? So for example, let's just say I have something like a live wire right here. Then of course I draw a fuse. And I close the switch, and I have maybe something like a metal casing. So inside the metal casing is maybe a heating element. I draw in the picture of a resistor. Then after that, I draw a neutral wire. Okay, so in the event of an electrical fault, what is an electrical fault? Electrical fault means something like maybe the live wire. Over time, right, the live wire might touch the metal casing, and this metal casing will be connected to something called the earth wire. In the event like this, right, there will be excess current flowing in the so-called electrical appliance. So what happens is that the current flow, right, when you hit the fuse, because the fuse there's a rating. So for example, let's just say the normal operation of this electrical appliance is 2 ampere, but of course the fuse is 3 ampere, right? After that, when the live wire touch the metal casing with the earth wire connected to the metal casing, right, there will be excess current flowing. So for example, let's just say I put the 3 ampere here. The excess current flowing is maybe 20 ampere, for example. So this will cause the fuse to melt and break. So that only this part of the electrical circuit is live. So normally, if this part of the electrical circuit is live, right, I will not be in danger, even though I touch the circuit right here, or maybe I touch the switch right here, because only this part is live. Okay, but if let's just say I have something like a fuse, and this fuse is connected to the neutral wire, of course the switch I will just place it right here first. Okay, so this is the case where I have something like this, right? So I close the switch. Okay, so I close the switch, so of course the current will flow. Okay, and in the event that over time, right, the live wire touch the metal casing of the electrical appliances, so this will cause excess current to flow. Of course the excess current will cause the fuse to melt. But the fuse is right here on the neutral wire. So when you cause the fuse to melt, so let me just denote down, the potential at this part will be at 240 volts. Okay, so all this part will be at 240 volts. The yellow shaded region will still be at 240 volts, even until this neutral wire, or until of course the breaking of your fuse. So all this yellow region is your 240 volts potential. And in the event that I touch the switch, or I touch the metal casing of the electrical appliances, which I'm connected to the 0 volts, because I'm standing on the ground, which is 0 volts, I will get electrocuted, because 240 volts will flow through my body to the ground. So this is actually quite dangerous. So that's why we don't put fuse on the neutral wire, because this will cause electrical shock. This will cause your metal casing to be live, even though the fuse has melted. Yeah, so that's why. Okay, the next thing is I want to talk is your fuse. Why must it be located before the switch? Okay, so the reason is very simple. So for example, let's just say I put a switch here. Put a fuse here. Then after that, I put a switch here. Okay, so there's a live wire connected to the electrical appliances. Let me just draw. So this is a heating element with a neutral wire. Okay, so don't forget that there's always an earth wire right here. So the earth wire is 0 volts. Okay, so in the event that there's an electrical fault, so the so-called maybe the live wire has a fray touching the metal casing, so this will cause the excess current to flow. And when it reaches the fuse will melt and break the circuit. So only this part is live. is the yellow region is live. So normally when I touch the electrical appliance, it's either I touch the outside of this part or the switch. So actually I'm quite safe because only this is 240 volts. So I touch this is 0 volts, I touch this is also 0 volts. So I'm not I will not get electrocuted in this sense. Okay, but however, if my fuse is placed after the switch. Okay, so for example, let's just say I draw. Okay, so in the event that my fuse is placed after the switch, yeah, okay, so if let's just say same thing, I have a live wire touching the metal casing, of course with an earth wire, right? Okay, so the excess current will flow, okay, and flow through the switch, and of course will break the fuse now, break it, okay, but however, right, this yellow region part is still live. It's 240 volts. Live means 240 volts. And in the event that I touch this switch, I'll get electrocuted because 240 volts passes through me down into the ground of 0 volts. So this actually is quite dangerous. Even though I can open the switch. Okay, let's just say I open the switch. Okay, so but this switch part is still live. Yeah, so that's why we must always put the fuse before the switch.